Welcome to School of Next Gen. Today we are going to explain very basic about vector. And here we're started with the parallelogram theorem. So let's start with P and Q are two vectors. And by the law of parallelogram said that these two vectors are at a common point or adjacent point O, and obviously they have a resultant will be its diagonal, and let's say the resultant is R. By the parallelogram theorem we can write down the equation. R is equals to, say, this is P vector, so P square plus Q square plus 2PQ cos alpha, and this alpha is the angle in between P and Q. So this is the alpha. So again, this is a P vector and this is a Q vector, and the resultant is R. So R is equals to square root of P square plus Q square plus 2PQ cos alpha. And the direction of the resultant. Indeed, we have taken P vector is the reference. So from P, let's consider this is the angle of theta. So from the P vector, the resultant is R, right? So we have to calculate the value of theta. So the direction of the resultant, the equation have to use tan theta is equals to P is the reference vector plus Q cos alpha and Q sin alpha, right? So what will be the value of theta? Nothing but theta is equals to tan inverse Q, this will be sin alpha over P plus Q cos alpha. So this is the value of the theta. So here is the vector P and here is the vector Q. In between these two vectors, let's say the value of alpha is equals to 90 degree. It means they are associated within at right angle. Indeed, what will be the value of R? So we know the value of R is equals to P square plus Q square plus 2PQ cos 90 degree, and this will be the square root. So what is the value of cos 90 degree? Obviously 0. So the value of the resultant will be P square, Q square, and the square root. And here, this is P vector and this is Q vector, and obviously in between these two vectors there is no angle. It means the value of alpha is equals to 0 degree. Indeed, the resultant R is equals to P square plus Q square plus 2PQ cos 0 degree, and obviously this is square root. So here we'll get P square plus Q square plus 2PQ and cos 0 degree is equals to 1. So this will be the square root. So we could write down P plus Q whole square, and this will be P plus Q, correct? And here the case number 3. So this is vector P and this is vector Q. and in between these two vectors, alpha is equals to 180 degree. Indeed, the resultant R is equals to p square plus q square plus 2pq and cos 180 degree. Of course, this is square root. So p square plus q square plus 2pq, and this is minus 1 because cos 180 degree is minus 1. Of course, this will be the square root. So this will be p minus q whole square and square root. So square root square cancel out. So this will be p minus q. So this is the value of r as well. So when alpha is 90 degree, it means the two vectors align within a right angle. In that case, we'll have p square plus q square square root, and r is equals to p plus q. When alpha is equals to 0 degree, it means they are in parallel. When they are in parallel, and when alpha is equals to 180 degree, it means one vector is going within this direction and another vector is going opposite direction. It means it will have p minus q. So if we put through the value of p and q for same value for this three case, obviously we'll get this will be the maximum value, and obviously this will be the minimum value. So if two vectors are opposite direction, in that case we'll have the minimum value, and when they're in parallel, in that case we'll have the maximum value. It means the sum of these two vectors will be the maximum value, and when it is perpendicular, perpendicular, in that case we'll have p square plus q square under square root. Here is a numerical problem. The maximum and the minimum values of resultant of two forces acting at a point, that is 12 Newton and 2 Newton, the maximum and the minimum values respectively, right? It means if there are two vectors, say there are two vectors, one is p, another one is q vector, right? So the maximum value, we have p plus q is equals to 12 Newton, and the minimum is p minus q is equals to 2 Newton, right? So what we have to calculate? We have to calculate the magnitudes of these two vectors. So we have to evaluate the value of p and q. So here we'll have 2p because this one cancel out, and this will be 14, right? So p is equals to 7, and of course if you put through here the value of p, it means q is equals to 7 minus 2, it will be 5 Newton. So this is the value of p, and the value of q is equals to 5 Newton. Now if you ask me the direction of the resultant, so if we would like to calculate the direction of the resultant, we have to have a value of angle between these two vectors. It means we have to know the value of the angle alpha, and let's say this is p, which is 7, and this is q, which is 5. If we have got the value of alpha, then we have to have the value of the resultant, right? By the way, what is the value of resultant here? Of course, r is equals to 7 plus 5, so this is 12, right? So this is the resultant value. But if you like to calculate the direction, it means, say, this is the resultant and the direction from P. So we have to calculate the value of theta. Indeed, theta is equals to P plus Q. This will be cos alpha and Q sin alpha. So if you plug in the value of alpha here as well as here, so we'll have the value of theta. But unfortunately, we haven't got the value of alpha. That's why we can't solve the problem. Anyways, here is a problem. So this is the problem number 2. And this is the extended problem of the previous one. So here maximum and minimum values of the resultant is 15 and 7 respectively. And there is another condition. If the magnitude of both forces is increased by 1 Newton, then the new forces are mutually perpendicular. Then determine the magnitudes of the forces and the angle between them. I mean the direction, right? So by the question, so we could write down according to question ATQ, P plus Q and P minus Q. So P plus Q is equals to, let's say 15, and P minus Q is equals to 7, right? From here, we could evaluate the value of P. So this one and this one will be cancelled out. So here will be 22, and of course the value of P is equals to 11. Same way we could find the value of Q. So Q is equals to P minus 7. So the value of P is 11 minus 7. So we could write down the value is 4. So here is Newton as well as Newton here as well. Anyways, now the second condition or the second part of the question say if the magnitude of both forces, so here the forces is increased by 1 Newton. So we have to write down according to condition 2. So number 2 condition, it will be P plus 1, it will be 11 plus 1, so the force will be 12 Newton. And again Q plus 1, so 4 plus 1 is equals to 5 Newton. So before it was 11, now increased by 1, now 12, and now 5 Newton. And when this happened, I mean increased by 1 Newton, that case the new forces are mutually perpendicular. So indeed, so let's say this is the value of P, which is 12, and this is the value of Q, which is say 5 Newton, right? And obviously in between these two vectors angle is 90 degree as they are mutually perpendicular. By the definition of resultant equation, R is equals to P square plus Q square plus 2PQ cos 90 degree. So if we plug in the value of 12 square here and 5 square here as well as here and here, and obviously here is 90 degree. After calculated this value, we'll find the resultant is 30 Newton. Right? Now, if you like to calculate the direction, it means theta. So, of course, it will be tan inverse, and here Q sine 90 degree, and here P plus Q cos 90 degree. Right? So this will be tan inverse, and of course sine 90 degree is 1, and this is become 0. So we could write down the value of Q is equals to 5, and value of P is 12. Right? So after calculation, we will have 22.62 degree. So here is the vector P, and here is the vector Q, and they are perpendicular. It means they are 90 degree, and the resultant actually this will be this will be this will be 22.62 degree, and this is the resultant.